Tonight we're sitting with the biggest quiet fact in all of science. The universe is dying, and it has been dying since its very first second. Nothing has gone wrong. It is winding down the way a fire settles, and the strangest proof is one you've seen every night of your life, the plain black dark between the stars. If the universe were the everlasting thing it feels like, there would be no gaps between the stars at all. The whole sky would blaze like the surface of the Sunday. The darkness you fall asleep under is the universe quietly admitting it was lit once, and that it is going out. And here's the part almost nobody knows. Humanity has known about the ending for longer than we've had light bulbs. It wasn't found through a telescope, it fell out of the mathematics of steam engines, and the men who found it slept fine. Tonight you'll find out why. We'll watch the whole story, from the lighting of the fire to the last warm thing going dark, and find what they knew, that almost every star that will ever shine has already been born, that the ending is the gentlest one physics knows how to write, and that if the universe were not dying, there would be no stars, no mornings, and no you. If these journeys help you rest, a like or a subscribe is the kindest way to say so, and leave a comment with where in the world you are drifting off from. It's always bedtime somewhere. For now, dim the lights and settle in. I'll keep watch. Now, you're lying somewhere warm, and the day's last warmth is cooling into the walls exactly the way it should. Let's begin. Start with a fire, because everything tonight is in the fire. Picture one banked low in a stone hearth at the end of a long evening, the kind you can watch without thinking. Orange settling toward red, red settling toward that deep, patient glow that seems to breathe. Nobody looks at a fire like that and calls it a tragedy. It is doing the most natural thing warmth ever does. It is spreading out. The heat that was crowded into the wood is unpacking itself into the room, into the stones, into the night beyond the window, thinning as it goes, and the moment you can name what the fire is doing, you can name what the universe is doing, because they are the same thing at two very different sizes. The universe was lit once, impossibly hot and impossibly crowded, and it has been unpacking its warmth into the dark ever since. Tonight is simply the story of that unpacking, told slowly, all the way to the end. And let's set the terms of the night right here, so your shoulders can stand down early. Tonight contains no catastrophe. Nothing in this story arrives suddenly, nothing chases anyone, and every single ending in it, even the nearest, sits further from your bed than 1 billion years, which is 5,000 times longer than there have been humans. The universe is dying is not an event you are caught in. It is a landscape you get to look at, from a very comfortable distance, wrapped in a blanket that exists because of it. Some nights this channel takes you somewhere with weather. Tonight is not one of them. Tonight is a fireside, and the fire is the whole of everything. And we are simply going to watch it burn low together until you're asleep. The rule underneath the fire has a stern name, the second law of thermodynamics, but you have known it in your body your whole life. Tea cools, toast goes cold, bathwater forgets it was ever hot. Warmth flows from warmer things to cooler things, always in that direction, never on its own the other way, and no one has ever caught it cheating, not once, in any laboratory, anywhere. Physicists measure the spreading with a quantity they call entropy, which sounds forbidding and simply isn't. Entropy is a count of how spread out, how mixed, how settled things have become. Low entropy means concentrated, ordered, wound up like a spring. High entropy means dispersed, blended, relaxed. And the second law says only this: left to itself, the world moves from wound up toward relaxed. Milk stirs into coffee and never stirs back out. A shuffled deck does not deal itself into perfect suits. The universe, taken as a whole, mixes, spreads, settles, and does not unsettle. And here's the part that makes this a bedtime story rather than a physics lecture. That One-way flow is the reason there is such a thing as before and after. Think about what makes a film look wrong when it runs backward. Shattered cups leaping whole onto tables, smoke funneling down into a chimney and packing itself into wood. Nothing in the backward film breaks the laws of motion, and yet you know instantly, in your stomach, that time doesn't go that way. What you're recognizing is entropy. The direction in which things spread and settle is the direction we call forward. One of the great astronomers of the last century, Arthur Eddington, gave it the name it still carries, the arrow of time. The arrow points along the spreading. Your memories sit on one side of it and your mornings on the other, and the reason tonight will become tomorrow rather than yesterday is, at the very bottom, the same reason tea goes cold. You are, right now, lying in a whole theatre of the second law, and it might be the coziest way to meet it. Listen to the house. The radiator ticks as it surrenders the boiler's heat to the hallway. The bathwater upstairs is quietly handing its warmth to the enamel to the air to the window glass, the glass to the night. The refrigerator hums in the dark kitchen, and the hum is the sound of a small local rebellion. It forces heat to leave a cold place and enter a warm one, exactly backwards, and it gets away with this only by spending order bought from a power station, which spends fuel, which was sunlight once. Run the ledger honestly, and the fridge obeys the law as faithfully as the teacup, paying for its little island of cold with a slightly larger surcharge of warmth out the back. Every machine you own is either a water wheel in the flow or a toll it pays. Nothing in your house, nothing in any house, has ever broken the rule you're falling asleep inside. There is something almost companionable about it once you hear it. The whole home, ticking and humming and cooling in agreement, all night, everything moving the same direction as you drift. Sit with how strange and how kind that is for a moment. The law that says the universe must run down is the same law that gives your life its order. First things first, and last things last. Childhood before old age. The question before the answer. A universe that never ran down would be a universe where nothing could ever happen next. So when we say the universe is dying, we are also saying, in the same breath, that the universe has a direction, a story, a place it is going. Dying, it turns out, is just what having a future costs. Now, the man who saw all of this most clearly lived in Vienna more than a century ago, and his name was Ludwig Boltzmann. He was the one who worked out what entropy actually counts. Heat, he said, is just motion, countless atoms trembling and colliding, and entropy is a tally of arrangements, of how many different ways the atoms could be shuffled without you noticing any difference from across the room. A tidy, wound-up world can be arranged in only a few ways, like a deck fresh from the factory. A settled, blended world can be arranged in unthinkably many, and things drift toward the blended state for the humblest reason in all of physics. There are simply more ways to be blended than to be tidy. The universe is not being pushed toward its evening by some stern hand. It is wandering there, step by step, because almost every step there is leads that way. Boltzmann fought his whole life to make the world believe atoms were real, and he did not live to see how completely he would win. On his gravestone in Vienna, above the grass, is carved not a prayer but his equation, the little formula that counts the arrangements. It may be the only tombstone on earth whose epitaph explains, gently and exactly, why everything on earth ends. People sometimes assume this is new knowledge, some cold gift of the space age, and it isn't. The ending has been on humanity's desk for 170 years, and the story of how it arrived belongs in tonight's telling. It arrived by steam. In the 1850s, in the great age of engines, physicists like William Thomson in Scotland, later Lord Kelvin, and Hermann von Helmholtz in Germany were doing something that had never been done. working out the exact bookkeeping of heat and work, the rules of the boiler and the piston, the young science of thermodynamics. And Thompson, following the new rules honestly, noticed that they refused to stay inside the factory. If heat always spreads and never regathers, then the great furnace of the sun is spending a capital it cannot replace. And so is every star, and so is everything. He wrote it up in a short paper, with a title that still reads like a bell tolling in a quiet room, on a universal tendency in nature to the dissipation of mechanical energy, and within a few years he and Helmholtz had said aloud what the equations implied. The universe is running down, and there will come a day, unimaginably far off, when nothing warm is left to flow. Sit for a second with what that must have felt like in a Victorian lecture hall, gaslit, upholstered, certain of progress if it was certain of anything. No telescopes had found the ending, no comet carried it. It walked out of the mathematics of steam engines, of all humble things, and it walked straight into the century's poetry and pulpits and dinner arguments, because everyone could feel what it meant. The strong Victorian word for it stuck, and we have used it all night: heat death. Some raged against the idea, some found it liberating, and at least one physicist observed correctly that the schedule was too generous to lose any sleep over. But the deepest response, I think, is the one tonight is quietly building toward. They had discovered that the universe is a story rather than a state, that it has a direction, a beginning implied behind it, and an ending implied ahead, and every cosmological discovery since, the expansion, the Big Bang, the afterglow, has been a confirmation and enrichment of that single Victorian realization. The people who first understood the fire also, in the same breath, first understood that it had been lit. And one more small kindness from that era, worth pocketing before we move on. Kelvin, who saw the dissipation first, lost no composure over it. And his reasoning was the same one you are welcome to borrow tonight. A law that promises the fire will someday finish is also a law that promises the fire is real, that its warmth is genuinely being given, not merely displayed. Nothing about the gift is diminished by the fact that giving is what it is. The tea in your hands cools because it is actually handing you its warmth. So does the sundae. So does everything. The Victorians' devotion to this law produced at least one scene too charming to leave out, and the story goes that it happened on a honeymoon. James Joule, the Manchester brewer's son whose careful experiments proved that motion and heat are the same currency, was so consumed by the idea that when he married in the summer of 1847 and travelled to the Alps, he reportedly packed, among the luggage, an enormously long thermometer. His plan was to measure a waterfall from top to bottom, because if falling water truly converts its motion into warmth, then the pool at the bottom of a cascade should be the tiniest fraction of a degree warmer than the lip at the top. The story is told by the other great thermodynamicist of the age, a young William Thompson, who claimed to have run into the newlyweds near a famous cascade at Chamonix, bride nearby, groom wading about with his thermometer, hunting a difference too small for the instruments of the day to catch. Historians still argue over how much of the tale grew in the telling, and it hardly matters. The picture is the truth. A man so in love with the great law of spending that he spent his own honeymoon asking a waterfall to confirm it. The waterfall, for the record, does warm its pool by about 1/4 of a degree for every 100 meters of fall. Exactly as he believed, and every cascade on Earth has been quietly proving him right ever since. So that's the law of the fire. Warmth spreads, arrangements blend, the arrow points forward, and none of it can run in reverse, which means the next question is really the whole mystery of tonight. And it's worth saying slowly. If the universe has been spreading and settling for nearly 14 billion years, if everything only ever runs down, then everything we see, every star, every galaxy, every warm-blooded creature on this one blue world, is running on a supply of order that was loaded in at the start. So who wound the spring? Why did the universe begin wound up at all? Hold that question, because the honest answer is one of the loveliest secrets in science, and to reach it we have to go back to the lighting of the fire itself. Picture the universe in its first age, a fraction of a second old, hotter than the heart of any star that would ever exist, everything that would ever become anything pressed into a space smaller than a thought. No stars, no atoms even, just a dense glowing fog of energy, expanding, and as it expanded, cooling. Within minutes it was cool enough for the simplest atomic cores to form. Hydrogen and helium, the ash and kindling of everything to come. And then, for a few 100,000 years, the whole universe was simply an oven, a glowing fog of light and matter, everywhere, the same blazing temperature, slowly dimming as it stretched. Then came a moment worth slowing down for, because the universe only ever did it once. Around 380,000 years in, the stretching fog finally cooled past the temperature of a star's surface, and the electrons, which had spent the whole age until then careening free and batting light back and forth, settled at last into orbit around the atomic cores and formed the first true atoms. And with the electrons captured, the fog did something no fog on Earth ever does. It became perfectly clear, everywhere, all at once. Light that had been trapped in the glow since the beginning was suddenly free, and it has been traveling ever since. That first released light is exactly the old warmth we will meet again later tonight, still arriving at our antennas from every direction, the oven's glow gone cold on a 14 billion year journey. The universe, from inside, would have looked like a sunset, completing itself in every direction at once. Orange deepening to red deepening to darkness, as the glow stretched out of sight of any eye that could have watched, and then darkness. Full darkness, everywhere, for something like 100 million years. Astronomers call this stretch the cosmic dark ages, and I find it one of the most restful facts in all of history. Before anything we would call a night sky, the universe itself kept one long, unbroken night. No stars, no light of any kind, except the fading ember glow of the beginning, just black gas, slowly, invisibly, gathering along the seams gravity was drawing. Nothing watched, nothing could. The universe rested in the dark, the way a seed rests, whole futures folded inside it, in no hurry whatsoever. The ignition, when it finally came, was worth the wait. In the densest knots of the gathering dark, clouds of primordial gas folded inward for millions of years, warming as they fell, until, in the heart of one of them, somewhere no map will ever mark, the temperature crossed 10 million degrees, and hydrogen began, for the first time anywhere, to fuse. A light switched on in a universe that had never contained one. The first stars were, by every model we can run, giants, tens or hundreds of times the sun's weight. Furious blue-white beacons burning fast and dying young, and their light spread out into gas that had never been lit, carving glowing bubbles in the primordial dark, the first shapes the universe ever showed. And because they were giants, the first stars did the other first thing, the one that matters even more to you personally. They were the first to die. Within a few million years, a blink on tonight's clocks, the first generation began to end in the universe's first great detonations, and those endings were the first deliveries of everything interesting. Up to that moment, the universe's entire pantry held hydrogen, helium, and a rumor of lithium. Nothing else existed, anywhere. The first supernovae changed the inventory of reality, scattering the first carbon, the first oxygen, the first iron into the dark, seeding the clouds that would build the second generation, and the second seeded the third, and the third includes the sun, which is why there is such a thing as a nightstand for your tea to cool on. Astronomers have never yet caught one of those first stars directly, The newest space telescopes are hunting their faint stretched light at the very edge of the visible and finding teasing hints, but we have always been looking at their legacy. It is the floor and the mug and the hand around it. If the universe's whole story is one long evening by the fire, this was the striking of the match. 100 million years after the wood was laid. Here is the strange part, the part that sounds backwards until it clicks. That early fog was almost perfectly smooth. The same density everywhere, to within 1 part in 100,000. And smooth for gravity means wound up. It seems wrong. Surely a smooth fog is the settled state, the blended state, the milk fully stirred into the coffee. And for heat alone it would be. But gravity changes the rules of the game entirely. In a universe with gravity, spread out matter is the loaded spring, because gravity wants nothing more than to gather it, and gathering releases floods of energy. A smooth universe is like rain resting on a high plateau, calm to look at, but holding, in its height, the power of every river and waterfall it will ever become. The Big Bang did not hand the universe order in the shape of tidy structures. It handed the universe smoothness, and smoothness, with gravity waiting, was a mountain of stored tomorrow. Why the beginning was so smooth, so low in entropy, so perfectly wound, is a question physics still cannot fully answer. And tonight we'll let it stand as an honest mystery rather than dress it up. What we know is what the smoothness brought. As the fog cooled and thinned, gravity went to work on those 1 in 100,000 flickers of extra density, gathering them patiently over millions of years, and where enough gas gathered, it fell inward, and falling made it hot. And when the heart of a falling cloud grew hot enough, hydrogen began to fuse, and a light switched on that was not the fading glow of the beginning but something new. The first star. The plateau had released its first river, and with the first stars, the universe found the shape it would keep for its entire long middle age, the shape it still has tonight, outside your window. A star is not a defiance of the dying. A star is the dying, organized. Deep in its core, hydrogen packs itself into helium and releases heat. And that heat flows outward, from the fierce center to the cool surface to the freezing dark of space, a waterfall of warmth pouring down a temperature slope 70 million degrees tall. Every photon of starlight is a parcel of the great unpacking, order being spent, warmth being spread. The stars are not candles resisting the night. They are the night's own slow fireworks, the universe running down in its most beautiful possible way. And once you can see stars that way, you can finally see yourself that way, because you are downstream of that waterfall, right now, in your bed. The sunlight that grew the wheat in your last meal was entropy being spent in the sun's core 8 minutes before it landed on a leaf. The warmth in your blood at this moment is that same flow, passed from fusion to light to leaf to grain to you, still spreading, still obeying, on its way through your skin into the cool air of your bedroom and on, eventually, into the dark between the stars. You are not a bystander watching the universe run down. You are a place where the running down briefly becomes a pulse, a breath, a thought before sleep. Life is not the opposite of the dying. Life is the dying, dancing. You can even put a number on your own share of the fire, and it is a very cozy number. A resting human body runs at about the power of an old-fashioned light bulb, 80 or 90 watts of steady warmth, radiated from your skin into the room, all day, all night, your entire life. Through a thermal camera you literally glow. A soft lamp in the shape of a person, brightest at the heart and the head. That warmth is stardust 3 steps removed. Sunlight caught by leaves, packed into grain and fruit, unpacked again inside you, spent outward into the evening air. And when you pull a blanket over yourself tonight, notice what you're actually doing. Banking your own fire, the way a hearth is banked, slowing your little share of the great spending so it lasts comfortably till morning. A bed, seen with tonight's eyes, is a fireside built for one. And the fire is you. Let's give the middle age its due before we walk into the evening, because we live in it, and it has been magnificent. Astronomers call it the stelliferous era, the age of stars, and it is everything you have ever seen. For its first few billion years, the universe made stars the way a spring meadow makes flowers, recklessly, everywhere, whole galaxies blazing into being, colliding, merging, igniting new suns by the 100 billion. The busiest stretch, the universe's high noon, came roughly 10 or 11 billion years ago, before the sun existed, before the Earth was even a rumor in a cloud of dust. If you had eyes then, and somewhere to stand, the night sky of an average galaxy would have run 10 times brighter with newborn light than ours does now. And it was not just brighter, it was louder. In every way a universe can be loud. Galaxies at noon collided constantly, still crowded from the beginning, tearing spiral arms off one another and lighting rings of newborn stars where they struck. The giant black holes at their centers, gorging on the traffic, blazed as quasars, single points outshining their entire host galaxies. Visible, some of them, across nearly the whole of the observable universe, cosmic lighthouses marking the busiest harbors. Great star nurseries the size of constellations ran day shifts and night shifts. Giants born and detonating within a few million years of each other, seeding and reseeding the clouds faster than the clouds could tidy themselves. That was the universe in its rush hour, and every deep photograph we take of that era still shows it mid-shout. Tonight's universe, by comparison, has the volume turned nearly all the way down. The quasars mostly dark, the mergers mostly finished, the nurseries mostly closed. One modest star kindled here and there where a cloud still remembers how. After the day this channel assumes you've had, I suspect you can hear it correctly. The universe got the noisy part done early, before anyone had to sleep through it. And then, slowly, with no drama at all, the meadow began to go over to seed. Star formation eased, generation by generation, as the raw material ran thinner. It has been easing ever since. Today, across the universe, new stars are born at a few % of the old peak rate, which is a polite way of saying the great age of making is mostly finished. Most of the stars that will ever exist now. The universe of tonight is like an orchard in late summer, still heavy, still golden, still fully alive, but past its last big planting, and everyone in it, if they're honest, can feel the season. Why is the making winding down? Follow the fuel. Stars are made from cold gas, and every generation of stars locks some of that gas away forever, in stellar corpses, in dwarfs and cinders that will never return their matter to the clouds. Galaxies also leak. Their hot breath blows gas out into the deep where it thins beyond use. And the expansion of the universe, which we will meet properly in a little while, keeps pulling fresh supplies farther away. The kitchen is not broken. The pantry is simply, gradually, emptying, and no delivery is coming. Each new star is now a slightly rarer event than the one before it, and this will remain true, gently, forever. To be fair to the universe, it recycles with real devotion before it lets anything go. When stars end, they hand much of themselves back. The sun will return nearly half its substance to the galaxy in those drifting veils, and the giants give back even more, enriched with every element their lives cooked up. The returned gas cools, gathers, folds into the great clouds along the spiral arms, and becomes new stars. And this loop has run, faithfully, for 13 billion years. Our own sun is at least a third-generation star, brewed from the returns of 2 rounds of ancestors. Galaxies even run fountains, lofting hot gas high above their disks where it cools and rains back down as fresh raw material. a water cycle the size of 100,000 light years. The trouble is only that no recycling is perfect. Every loop, some fraction stays locked in embers and cinders, some leaks away on the galactic wind, and the great clouds thin, round after round, like a village passing the same flour tin between kitchens, and each time returning a little less. The universe is not wasteful. It is, if anything, the most careful spender there has ever been. It simply lives, like everything inside it, on a budget with no income, and it has been managing that budget gracefully since before there were witnesses. If that gives you a pang, hold on to this, because it's true and it helps. A slowing orchard is not a dead one, and the fruit that remains ripens for an almost unbelievable length of time. The universe's future is not a cliff. It is the longest, slowest dusk that could possibly be imagined. And the small stars, the humble ones, are about to become the heroes of the whole story. Before we walk out into the deep future, though, let's stop at the hearth we actually live beside, because the story of the dying universe runs straight through our own back garden, and it's better to hear it here, in the warm, than to meet it later as a stranger. The Sun is a middle-aged star, about 4.5 billion years old, roughly halfway through the hydrogen in its core. Every second, it converts millions of tons of matter into light, and it has done so without a single missed morning since before the Earth had a surface to warm. It will keep this up for around another 5 billion years. Whatever else tonight holds, hold this too. Nothing about our star is in a hurry, but stars age the way people do. From the inside first, quietly, as the Sun's core turns hydrogen to helium, the helium settles and crowds the furnace. And the furnace, squeezed, burns a little hotter, and the Sun, decade by decade, era by era, grows very slowly brighter. It has already brightened by something like a third since its youth. In perhaps 1 billion years, that gentle brightening will start to be too much for our particular blue world, and the long afternoon of Earth will begin, oceans thinning into the sky, over spans of time that make the age of the dinosaurs look like a single afternoon. It is a slow goodbye written into the physics from the start, and it is worth saying plainly, without flinching and without gloom, worlds have seasons too. Ours has been in bloom for 4 billion years, and its summer, though finite, is not close to over. And because a sleepy mind at this hour can quietly mistake cosmic clocks for kitchen clocks, let's say the scale out loud once and then let it rest. 1 billion years. The whole story of humans, every ancestor who ever chipped a stone or named a star, fits into that span 5,000 times over. If Earth's remaining summer were a single year, all of recorded history so far would be the last few minutes of December. And everything your descendants could plausibly become, every future you would recognize as ours, happens before the first morning of January. Whatever your family line grows into across even 1 million years, let alone 1,000 of those, it will not meet the sun's brightening as a surprise. It will have watched it, measured it, and had spans of time beyond imagining to answer it, or to have long since become something for which it is not a question. The far futures in tonight's story are not hanging over anyone you will ever love. They are simply the landscape's far hills. Lovely, pale blue with distance, and no road you care about runs off the edge of them. Since we're being honest about slow goodbyes, there is one more happening quietly overhead, and it is so gentle and so strange that it belongs in tonight's collection. The moon is leaving, not dramatically and never completely, but the tides it raises on Earth push it very slowly outward, and it drifts away from us by about the width of 2 fingers every year. Nothing about your sky will change in any lifetime, or in 1,000 lifetimes, but the moon and the sun currently perform the most improbable coincidence in the solar system. The sun is around 400 times wider than the moon and also around 400 times farther away, so the two disks match in our sky almost exactly, which is the only reason a total solar eclipse, that perfect black coin ringed with silver fire, is possible at all. As the moon eases outward, its disk slowly shrinks against the sun's, and somewhere around 600 million years from now, give or take an age, the fit will fail for good, and the Earth will host its final total eclipse. Someone, or something, may be there to stand in the last of that impossible shadow. Every eclipse until then is one of a long but finite series, which is worth knowing the next time you see one. The universe's slow goodbyes are not all cosmic and distant. One of them is written directly over your roof, in the gap between two circles of light. The sun's own ending, when it finally comes, will be the most beautiful thing it ever does. With the core's hydrogen spent, the furnace moves outward into fresh fuel, and the sun will swell, over hundreds of millions of years, into a red giant, vast and cool and gentle at its surface, a soft, enormous lantern where a fierce yellow star used to be. It will swallow Mercury, almost certainly Venus, and possibly the quiet cinder that was once Earth, though the calculations still argue with each other about that last mouthful. And then, unable to hold its outer layers, it will let them go. Slowly, in overlapping veils, the sun will exhale its own atmosphere into space, glowing shells of gas lit from within, drifting outward like rings of coloured smoke from a lamp. Astronomers call these planetary nebulae, and they are among the most delicate sights a telescope can find. The last breath of a star arranged in light. Everyone you have ever seen a photograph of was a hearth like ours, letting go. What remains at the centre when the veils drift clear is the part of tonight I find quietly wonderful. A white dwarf, the sun's old heart, compressed to the size of the earth, no longer burning anything at all. A spoonful of it would weigh as much as a car. It makes no new heat. It simply is heat, a stored ember of everything the sun ever was. And from the moment it forms, it does the only thing left to do, which is cool, slowly, patiently, on a schedule that embarrasses every other slow thing in nature. A white dwarf takes longer to fade than the universe has currently existed. The sun's ember, born 5 billion years from now, will still be faintly warm when the cosmos is 10 times its present age. When you picture the far future, don't picture ash scattering. Picture 10 billion trillion Earth-sized embers, each one the kept heart of a star, glowing softer and softer across spans of time we have no stories for yet. And we know exactly what such an ember looks like, because one of them lives 9 light years from your bedroom. And the story of how it was found is a small masterpiece of patience. In the 1840s, the great German astronomer Friedrich Bessel noticed that Sirius, the brightest star in our sky, was not travelling in a straight line. It wobbled gently, with a rhythm of about half a century, as if something unseen and heavy was swinging it in circles. Bessel announced, with magnificent confidence, that Sirius had an invisible companion, and then he died. And for 20 years the companion stayed a prediction. It finally appeared in 1862, and the discovery was an accident of quality control. A master lensmaker in Massachusetts, testing the largest telescope lens ever made in America by pointing it at the brightest convenient star, saw a faint tiny spark hiding in Sirius's glare, exactly where the wobble demanded. Astronomers, who cannot be stopped, nicknamed the big star the dog star's companion the pup, and half a century later came the real shock. The pup's weight is about the sun's, but its size is about the Earth's. Matter packed so tightly that a matchbox of it would need a truck to lift. The astronomers of that era refused to believe it at first, and one of them famously grumbled that the result was nonsense. It wasn't nonsense, it was the future. The pup is a white dwarf, the first ever recognized, a preview of our own suns forever, sitting politely beside the brightest star of winter, and you have almost certainly looked straight at it without knowing. And the small stars do even better than that, because the small stars barely die at all. Here is one of the kindest jokes in astronomy. The future does not belong to the giants. The blazing heavyweight stars, the ones that light up whole spiral arms, spend themselves in a few million years and are gone. The sun, modest and steady, gets 10 billion, but the red dwarfs, the little dim patient stars too faint for your naked eye, every single one of them, sip their fuel so slowly and stir themselves so thoroughly that the smallest will burn for something like 10 trillion years. 10 trillion. That is around 700 times the current age of the universe. Proxima Centauri, the nearest star to our sun, that faint red neighbour 4 light-years down the road, will still be shining steadily when every star you can see tonight, every single one, has been dark for longer than the universe has yet been alive. The meek do not merely inherit, they outlast the inheritance. Let yourself see one of those far future evenings for a moment, because it is a real place and time on the universe's calendar, and someone or something may well be there for it. A world in close orbit around an old red dwarf, tide-locked, one face always toward its star, warm on one side and starlit on the other, with a band of permanent dusk running between them like a seam of honey. The star hangs low and enormous and unmoving in that dusk sky, the colour of a fire's last hour, and it has looked exactly like that for 100 billion years, and will look exactly like that for trillions more. No seasons, no sunsets, no hurry of any kind. If there are watchers there, their word for patience must be magnificent, and their astronomy will be a strange inheritance. A sky of embers and elders, a museum sky, with the great bright chapters legible only in fossil light. We think of red as the colour of endings. Across the deep future of the universe, red is simply the colour of continuing. So the age of stars does not end the way a candle gutters. It tapers magnificently. The bright and brief go first, then the middleweights like ours, each leaving its ember, and the sky hands itself over trillions of years, to the small red keepers of the flame. Some astronomers make an honest and rather hopeful argument that the friendliest ages for life might still be ahead, in the impossibly long calm of the red dwarf era, when trillions of steady little suns will each have hundreds of times longer than Earth has had to try the great experiment of chemistry waking up. We tend to assume we arrived at the party late. It is at least as fair to say we arrived early, in the loud opening hour, before the long quiet stretch when the conversation gets good. While the stars are tapering, the map is changing too, and we should mark it, because it sets up everything the deep future becomes. Our Milky Way and the great Andromeda galaxy, mutual neighbours and mutual destinations, are drifting toward one another. And in around 4 or 5 billion years, right about when the sun is swelling red, they will begin a merger lasting billions of years more, 2 spirals folding together into one large calm galaxy of embers and elders. If anyone is there to watch, it will be less a collision than a change of address. The stars themselves are so far apart that they will pass among each other like 2 flocks of birds merging in the air, hardly a feather touched. The local family of galaxies, bound by gravity, will gradually gather itself into this one final household. And everything beyond the family, every distant galaxy you have ever seen in a deep photograph, will meanwhile be doing something much stranger, which we will come to soon. Leaving, it's worth pausing on what the night sky itself will do during the merger, because for once the deep future offers a show rather than a fading. As Andromeda closes in over the next billions of years, it will slowly swell in Earth's sky, or whatever world's sky, from a faint autumn smudge into a vast tilted spiral of light spanning many moons bright enough to notice over city glow. A second galaxy hanging above the rooftops like weather. Then, across ages, the two great wheels will tangle, throw glittering tidal streamers of stars across the dark, light up in a last burst of star-making as their gas clouds collide, and finally settle, over more ages still, into one enormous, calm, golden swarm. The band of the Milky Way, the river of light our ancestors navigated by, will unbraid itself and become a gentle, all-sky glow of old suns. Astronomers, with the affection of people naming a grandchild, already call the future household Milkomeda. Nobody alive will see it, but it is not nothing to know, lying in the dark tonight, that the sky has appointments, and keep one small thread of continuity through all of it, because it makes the far future personal. Somewhere in that merged golden household, on some long elliptical orbit among a trillion others, the sun's own white dwarf will be riding, our star's kept heart, still faintly warm for ages after the merger settles, carrying in its crystallizing depths the memory of every morning Earth ever had. Whatever the far future forgets, it will still contain, in the most literal way, the thing that warmed every story you have ever been part of. The hearth travels. It dims, but it travels. First, though, walk with me past the last star, because there is a night coming after the tapering, and tonight is the right, safe place to see it. Somewhere around 100 trillion years from now, give or take an age or two of the universe, the final star will form out of the last usable pocket of the last usable cloud, and it will almost certainly be a small red one, a modest final child at the end of an unimaginable family line. It will live its 10 trillion years the way all its kind do, faithfully and without spectacle. And when it fades, the stelliferous era, the age of starlight, the only age you and I have ever known, will be over. The sky of every world that still exists will hold embers and darkness, white dwarfs cooling toward black, and the long second half of the universe's story will begin, the half with no new light in it. I know how that sentence lands at night, so let me set the two warm facts beside it right away. First, the age of starlight, from the first star to the last ember worth the name, spans something like 100 trillion years, and we are 14 billion years in. As a fraction, the universe's whole bright chapter has barely started, if the age of stars were a single night's sleep. The universe right now has been asleep for about 4 seconds. Second, nothing in the darkness that follows is violent. There is no wall of cold that arrives, no lights switched off at the mains. There is only the same gentle law we started with at the hearth, warmth spreading, arrangements settling, everything relaxing its shoulders on longer and longer time scales, forever. The universe's ending is not an event. It is a mood, arriving over spans of time that make the word slow give up entirely. Before we walk the quiet ages one by one, let's be honest about the numbers ahead, because they are about to leave every human scale behind. How long is a 1 followed by 40 zeros of years, really? What could that possibly mean to a creature who counts birthdays? There is a trick to holding numbers like these, and it works better than gasping. The trick is to stop hearing them as amounts and start hearing them as rhythm. Try this one. Take the entire age of the universe so far, everything from the first blaze to this evening, all 14 billion years of it, and call it one tick of a clock. One tick, 14 billion years. The age of stars. From first light to the last flicker of the smallest red dwarf runs about 7,000 ticks. Now let the clock keep going. The embers take tens of thousands of ticks just to finish cooling into darkness. The patient dissolving of matter, if it happens, takes so many ticks that you would need to tick once a second for far longer than the universe has existed just to count them. And the evaporation of the last great black holes takes a number of ticks that has no name, a 1 followed by 90 or so zeros, a number that does not describe anything else in science, nothing, except this one patient process. The universe's calendar has pages beyond pages beyond pages, and everything we have ever called history is a mark in the corner of the first one. Or make it physical, because paper sometimes holds what the mind cannot. Suppose you decided to write the number of years until the last black hole finishes, and you wrote it the long way, a 1 followed by all its zeros, 1 0 per second, unhurried. You would be done in under 2 minutes. The number fits on a single line of a notebook. That is the strange mercy of mathematical notation. An eternity folded into a pencil stroke. But now suppose instead you tried to weight it, second by second, and marked a grain of sand for every year. All the beaches of Earth together hold something like a 1 followed by 20 zeros of grains. You would exhaust every beach on the planet, then every beach on 1 billion planets, and you would not have made a visible start. Somewhere in the writing of those zeros, the honest mind simply lets go, and that letting go is not a failure. It is the correct answer. Deep time is not something you are meant to hold. It is something you are meant to float in, the way you float in the sea precisely by not trying to grip it. And once you're floating, notice how the character of the far future changes. Nothing out there is crowded. Nothing overlaps. Events, which tonight on Earth arrive by the 1,000 per heartbeat, will eventually arrive one at a time, separated by gulfs of calm. A single merger here, a single final flash there, each with an era of stillness to itself, like bells rung across a valley at midnight, each allowed to fade completely before the next. The deep future is not a void. It is the most uncluttered schedule that will ever exist, and the universe will keep every appointment on it, unhurried, one tick at a time. So let's walk into it properly. The way you'd walk into a dark house you know is safe, one room at a time. Astronomers who think about the deep future divide it into great ages, the way we divide a life, and the age that follows the stars has a name that sounds harsher than it is, the degenerate era. The name is nothing sinister. Degenerate is simply the physicist's word for matter packed so tightly that the ordinary rules of squeezing give up, the state inside white dwarfs and neutron stars. And what does a universe actually do all day in an age like that? This is the age of remnants, the age of embers, and it is expected to last from the end of starlight out to numbers like a 1 followed by 30 or 40 zeros of years. Nearly all the matter that was ever in stars now rests in 3 kinds of keepsake: white dwarfs, the cooling hearts of ordinary suns, neutron stars, the city-sized, impossibly dense hearts of giants, and black holes, the ones that fell all the way. Around them drift the planets that survived, frozen, faithful, still keeping their orbits, because gravity does not need light to work, and a dead star holds its family as firmly as a living one. The dark galaxy is not still, though, and its slow habits are worth watching for a minute, because this is the last era in which anything we would recognize as happening still happens. The embers and cinders orbit the great household as the stars always did, and over spans of quadrillions of years, they occasionally pass near one another, and every close pass rolls dice with the families involved. A near miss can loosen a frozen planet from its dead star and send it wandering off alone. Given enough ages, most worlds will be unbound this way, orphaned into the dark with their oceans of ice and their unread geology. The passes reshape the galaxy too. Some remnants are flung outward entirely, evaporating the household one member at a time into the intergalactic dark, while the innermost drift gradually deeper, feeding, over unthinkable spans, the great black hole at the center. A galaxy in this era is like a fire's last hour sped into motion. Embers shifting, settling, occasionally tumbling from the grate, everything rearranging toward its final rest with no light to see it by. And the era keeps 2 small flames of genuine novelty, which I love too much not to hand you. The first, brown dwarfs, the almost stars. The balls of gas that were always just too small to ignite, will still be drifting through the dark in their billions, and once in a very great while, two of them will collide, and their combined weight will cross the old threshold, and a true star will flicker on, alone, in a galaxy that has forgotten starlight, and burn faithfully for trillions of years like a match struck in an empty cathedral. The second, even the settled embers, keep one last surprise. A white dwarf that gathers just enough from a companion can still, even in the deep dark era, cross its limit and detonate, one final standard candle with no astronomers left to calibrate it. The universe never fully gives up its habit of light. It just spaces the lights further and further apart, like lamps along a road heading out of town. Spare a bedside thought for the neutron stars through all of this, because they are the strangest keepsakes in the whole collection, and they age the most gracefully. A neutron star is what remains when a giant's core falls almost all the way. A sphere the size of a small city holding half again the sun's weight. Matter packed to the density of an atomic nucleus, a teaspoon of it outweighing a mountain range. The young ones announce themselves. They spin dozens of times a second, sweeping beams of radio light across the dark, like impossibly fast lighthouses, and when such a beam happens to cross the Earth, we hear it as a pulse, tick, 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 keeping time better than the atomic clocks we check it against. But the ticking is a spending too, and so, over millions and billions of years, each lighthouse slows, its beam fading, its rotation easing, until it turns, at last, in silence. In the deep eras, they will be the galaxy's most perfect timekeepers, still turning, once a year, once a century. Black spheres smoother than any ball bearing ever machined, each one holding, in its stillness, the compressed memory of a star that once outshone 100 million suns. If the far future has monuments, they are these. The quietest, roundest, most patient objects the universe ever made, keeping unlit time in the dark. The way we found them deserves its minute too, because it may be the best night shift story in the history of astronomy. In 1967, in a field outside Cambridge, a young graduate student named Jocelyn Bell was running a sprawling radio telescope she had spent 2 years helping to build out of wire and wooden poles, and her job was to read its output, which arrived as endless rolls of chart paper, nearly 30 meters of it every day, by hand. Buried in those miles of wobbling ink, she noticed a smudge she couldn't explain, half a centimeter of what she called scruff, appearing again and again from the same patch of sky. She chased it for weeks, and when the recorder was finally run fast enough, the scruff resolved into something no one had ever seen. Pulses, perfectly regular, arriving every second and a third, steadier than most clocks on Earth. It seemed so unnatural that the team half-jokingly labelled the source with letters standing for little green men and quietly wondered for a few weeks whether they had intercepted somebody's beacon. Then a second scruff appeared in a different corner of the sky, and a third, and a fourth, and relief arrived with them. No civilization arranges itself in all directions at once. What Bell had caught was the lighthouse sweep of spinning neutron stars, the first ever detected, the collapsed hearts of giants announcing themselves across the galaxy. The discovery reshaped astronomy. A Nobel Prize followed for the project. And though the committee of that era passed over the student with the chart paper, the field itself never has. Ask astronomers who found the clocks of the far future, and they will give you her name. Every pulsar timed tonight, and there are thousands, descends from half a centimeter of scruff that one patient person refused to ignore. The white dwarfs are the last warmth in the universe, and they spend this era doing the slowest thing you have ever heard described. Finishing cooling. Watch one across the ages and it slides from white heat to yellow, to orange, to a deep, tired red, and finally out of the visible altogether. An Earth-sized coal going from red-hot to merely warm. Warm the way a kettle is warm an hour after tea. Warm the way a chair is warm after someone leaves it. And then, at last, after spans of time that dwarf everything that came before, not warm at all. What remains is called a black dwarf, a sphere of crystallized stellar ash, dark as the space around it, still holding its shape, still orbited by its frozen worlds. That word crystallized is not a poet's flourish, by the way. It is a measurement, and a recent one. As a white dwarf cools through its long retirement, its interior, a dense soup of carbon and oxygen nuclei, begins at a certain depth of cold to freeze, the nuclei settling into a fixed repeating lattice, a crystal growing outward from the core over billions of years. Astronomers watching the great river of stars with modern survey telescopes have caught the signature, cooling white dwarfs bunching up at just the temperatures where freezing releases its last flush of stored heat, the way a pond hovers at the freezing point while the ice takes hold. Which means the far future's embers are not merely cooling, they are solidifying into single vast crystals of stellar ash, spheres of ordered carbon and oxygen the size of the Earth. The universe's last common objects will be, in the plainest sense of the word, gems. Dark, patient, Earth-sized jewels, each one the compressed and perfected heart of a star, orbiting in their quadrillions through the halls of galaxies that no longer make light. The dying universe does not decay into rubble, it anneals into treasure. The universe has never yet made a single one, there hasn't been time. The very first black dwarf is still quadrillions of years in the future. When you hear people say the universe is old, you can keep this in your pocket. Nothing in the universe has ever yet had time to finish cooling. It is early. It is so absurdly early. And even the embers, it turns out, may not be the final word, because matter itself might have a lifespan. The protons at the heart of every atom, the most reliable objects in all of physics, particles that have never once been seen to fail, may, according to several of our deepest theories, very occasionally, on timescales beyond all comprehension, quietly come apart. Nobody knows. Experiments have watched enormous tanks of water for decades, waiting for a single proton to give up, and none has, which tells us that if protons do decay, their typical lifespan is at least a 1 followed by 34 zeros of years, unimaginably longer than the age of stars. But if it happens, if matter itself is mortal, then across the degenerate era, the black dwarfs and the drifting planets, and every unclaimed pebble in the dark will, atom by atom, over numbers like a 1 followed by 40 zeros of years, dissolve into faint light and the lightest of particles, a mist finer than matter. The universe would forget, gently and completely, that there had ever been such a thing as a rock. The way humans have gone looking for that possibility is, in its own right, one of the most beautiful vigils in science. And it deserves its picture tonight. Deep under a mountain in Japan sits a tank holding 50,000 tons of water so pure it would leach the minerals from your bones. And the tank's walls are lined, floor to ceiling, with 13,000 golden eyes, photomultiplier tubes, each one a polished bubble the size of a beach ball, capable of noticing a single particle of light. The chamber is kept in perfect darkness. If a single proton, anywhere in all that water ever gave up and came apart, the flash of its passing would be caught by the golden eyes within a billionth of a second. Physicists have kept versions of this watch for 4 decades. Hundreds of trillions of trillions of trillions of protons under continuous guard, and in all those years, the water has never once flickered for that reason. Every quiet night in the tank pushes the proton's minimum lifespan higher. It is the strangest lighthouse keeping in the world, a lamproom built to see the smallest possible ending, staffed for 40 years, faithfully reporting nothing, and every report of nothing is a small poem about permanence. Hold that as a maybe, clearly labelled. Physics does not yet know whether the furniture of the universe is permanent. Either way, the story continues. because one kind of resident remains either way, and it is the strangest one. The age that follows is called the black hole era, and here the universe consists, almost entirely, of the ones that fell all the way, patient beyond all patience, holding whatever came too close, from the little ones a few times the sun's weight to the giants at the centers of dead galaxies weighing billions of suns. For an unthinkable stretch, nothing much happens except orbiting and merging and the slow evaporation of everything else. And then the last great discovery of tonight's story comes into its own, the one Stephen Hawking gave the world in the 1970s. Black holes are not quite forever. Down at the finest grain of reality, at the very edge of a black hole, the restlessness of empty space itself lets the faintest whisper of warmth leak away, a glow so weak that a black hole the sun's weight shines less than a single snowflake's worth of energy. But the universe, by this era, has nothing but time, leak by leak, over a 1 followed by 67 zeros of years for a star-weight black hole, and something like a 1 followed by 100 zeros of years for the giants. Even the deepest wells in existence give their substance back to the dark, thinning, warming faintly as they shrink, until, at the very end of each one, the leak becomes a trickle, the trickle becomes a rush, and the last of it departs in a single brief sigh of light. The final black hole's final flash may be the last event worthy of the word that the universe ever hosts. After it, the guest list is empty. If you could stand somewhere safe and watch a last flash, it would be a modest miracle to see. After an eternity as the darkest possible object, the shrinking hole would spend its final moments glowing, faintly at first, then brightly, a point of growing warmth in a universe that had forgotten the concept, ending in one swift final blaze, fierce by earthly measures, unnoticeable on the scale of the old universe. And then simply, completely, nothing, not even the darkness it used to be, just ordinary empty space where the deepest well in existence had waited out the ages. And the silence afterward would be a new kind of silence, because it would have no exceptions left. Every earlier quiet in the universe's story was a quiet between events. This one is the quiet after the last one. A reasonable sleepy question arrives here, and it deserves a straight answer before we go on. Could anyone be there for all that? Could life, in any form, keep any kind of company with the Dark Ages? The honest answer is that nobody knows, and the honest speculation, explored seriously by the physicist Freeman Dyson, among others, is gentler than you'd expect. Life as we know it needs warmth flowing, and warmth will flow, thinner and thinner, for ages beyond counting. Embers, evaporating holes, the last slow tolls of gravity settling accounts. Dyson's thought was that minds native to a cooling universe would not fight the cold but keep pace with it, thinking more slowly as the flows thin, hibernating across the gulfs, experiencing, perhaps, no poverty at all, because a thought that takes 1,000,000 years still feels, from inside, like a thought. Whether physics ultimately permits it is genuinely open, but it means the Dark Ages are not necessarily unwitnessed, and if they are witnessed, they will be witnessed the way you are witnessing tonight. Drowsily, patiently, with long, warm pauses between thoughts. The universe's last minds, if it has them, will be the sleepiest minds that ever existed, and they will be doing, on the grandest scale, exactly what you are doing right now. And notice what that does to the idea of an ending. If minds like that are possible, from inside a thought that slows with the universe, the end never quite arrives. Each era of cooling simply feels like a longer, calmer now, the pauses stretching, the urgency thinning, the way the space between your own thoughts is stretching at this very minute, without a single one of them feeling cut short. The universe's ending, experienced from inside at the universe's own pace, might feel less like a wall, and more like the world's most gradual falling asleep, each moment complete, each next moment a little further off. No final moment ever announcing itself as final. There is no scientific promise in that, only a permission. The shape of the far future depends on the clock you carry, and the universe, notably, does not carry one. And so we arrive, together, in the last age. And I want you to notice, as we do, how calm your breathing is, because we have arrived at the place the whole night was named for, and there is nothing here that can hurt anyone. The dark era, a universe of unbounded, ever-stretching space, containing a mist of the lightest particles and the longest light, spread thinner than any laboratory vacuum ever achieved. Every particle drifting farther from every other, the temperature of everything settling toward absolute zero without ever quite touching it, the way a note fades without ever agreeing it has finished. No stars, no embers, no clocks, no events. Nothing left that can happen next, because happening itself was always a flow from warm to cool, from wound to unwound, and here, at last, everything is even. Warmth has finished spreading. The fire that was lit 14 billion years before your bedtime has completed the one task it was ever performing. Physicists call it heat death, and now you can hear the name properly. Not death by heat, but the death of heat, the retirement of warmth itself. It is the universe, finally, deeply, and permanently at rest. That is the destination. And knowing it, you can now ask the question the title of tonight promised. The real question. The one the whole second half of our story turns on. Why this ending? Why not fire? Why not collapse? Why this long, gentle fade and nothing else? Because for most of the 20th century, astronomers genuinely did not know which ending the universe was headed for. And the story of how they found out is one of the best detective stories science has ever run. And it happened, remarkably, within living memory. To tell it properly, we have to pick up a thread we left hanging near the beginning. The expansion itself. Because the ending of the universe was always going to be decided by a tug of war between two forces, and everyone knew it. On one side, the outward stretch, space itself growing, carrying the galaxies apart, discovered in the 1920s when astronomers found that nearly every galaxy's light arrives stretched toward red, the unmistakable signature of a universe getting bigger. On the other side, gravity, the great gatherer, working patiently to slow that stretch, to halt it, and, if it could, to reverse it. Every possible future hung on the balance. If gravity was strong enough, the expansion would one day stall like a ball at the top of its throw, and the universe would begin to fall back into itself, hotter and denser and faster, all the way down to a mirror of its beginning, an ending astronomers called the Big Crunch, the fire relit by collapse. If gravity was too weak, the coasting would simply continue, slowing forever but never stopping, thinning out into the long cold we have already walked through. Two endings, fire or ice. And the deciding vote belonged to a single number, how much stuff the universe contains. For most of a century, cosmology's biggest question fit on a scale. Weigh the universe, and you would know how it ends. There was even a third possibility, mostly kept in a drawer, and it had been put there by Einstein himself, when he first applied his equations to the whole cosmos. Years before anyone knew the galaxies were fleeing, he found his mathematics insisting that a universe full of matter could not simply stand still, and, trusting the quiet eternal sky of his era's assumptions more than his own equations, he added a term to hold everything steady, a kind of built-in outward push woven into space itself. He called it the cosmological constant. When the expansion was discovered a decade later, the patch became unnecessary, and the story goes that he called it the biggest blunder of his life. The term was folded away in the drawer, not quite discarded, the way you keep a strange key long after you've forgotten the lock. Keep your eye on that drawer. Now, to weigh the future, astronomers in the 1990s needed to measure how the expansion had changed over cosmic history, which means they needed to compare the universe's stretch today with its stretch billions of years ago, which means they needed something in the deep past whose distance they could truly trust. They needed lighthouses again. A century earlier, it had been Henrietta Leavitt's flickering stars that first measured the galaxies. Those lighthouses were far too faint for this new job. What the 90s teams needed was a lighthouse, visible across half the observable universe, and nature, remarkably, provides exactly one, and you already know its main character, because it is our old friend from the middle of tonight, the white dwarf, the retired ember of a sun-like star. Here is how an ember becomes the brightest lighthouse in existence. Most stars live in pairs, and when a white dwarf orbits a living companion closely enough, it can, over ages, draw a thin stream of the companion's outer gas down onto itself, growing heavier, gram by stolen gram. But a white dwarf has a strict weight limit, a threshold of stability worked out in the 1930s by a young physicist named Chandrasekhar. About 40% heavier than our Sunday. That limit has a story of its own worth, a night lamp, because it was worked out by a teenager on a boat. In the summer of 1930, an Indian student of 19 named Subramanian Chandrasekhar boarded a steamer from Bombay to England to begin his studies, and to pass the long crossing he took the newest physics with him, the young quantum theory, and aimed it at a question nobody had thought to ask sharply: is there a heaviest possible white dwarf? Somewhere on the Arabian Sea, the arithmetic gave its answer: yes. Past a certain weight, no ember can hold itself up, and must fall. He arrived in England with the far future of every heavy star in his notebook. The great men of the field, one in particular, publicly ridiculed the idea for years, unwilling to accept what it implied about stars that fall all the way, and Chandrasekhar, with a patience the universe itself would approve of, simply carried on, wrote the result into a book, moved continents, and outlived the ridicule by half a century. The limit now bears his name. The Nobel Committee eventually agreed, and a great space telescope flies named after him. Tonight his teenage arithmetic is a load-bearing wall in the story of everything. It is why white dwarfs detonate at a standard weight, which is why the candles are standard, which is why we could read the universe's fate at all. A boy on a boat, bored between continents, quietly worked out the clause in the contract of stars, and it held. The moment a white dwarf is pushed past that line, it cannot hold, and it detonates, completely, in a runaway of fusion that for a few weeks outshines its entire galaxy. And because every one of these detonations is triggered at the same threshold, the same overloaded ember failing at the same weight, everyone flares with very nearly the same true brightness, refined by how quickly each fades. Astronomers call them Type 1, a supernovae. You can think of them as the universe's standard candles. Every flame struck from the same mold, so that how faint one looks tells you, cleanly and honestly, how far away it burned. The embers of dead suns, it turns out, are also the measuring rods of the cosmos. Tonight's story keeps folding back on itself like that, and I promise it isn't done. So, in the 90s, two rival teams set out to catch these flares in the deep past and read the universe's fate from them. One, led from Berkeley by Saul Perlmutter, was built around physicists and their stubborn machinery of automated searching. The other, formed a little later around Brian Schmidt and Adam Rees and their colleagues, came from the supernova astronomers themselves. The rivalry was real, sharpened by conferences and preprints, and the knowledge that the answer, whichever way it fell, was a piece of history. The work itself was a kind of choreography with the sky. Photograph wide fields of distant galaxies, wait through the dark of the moon, Photograph them again, and hunt the pairs of images for a single new point of light. A detonating ember billions of light years away, caught in its few good weeks. Then, quickly, beg time on the great telescopes to catch the fading, measure the stretch of its light, add one more candle to the graph. Candle by candle, year by year, the two teams were drawing the universe's speedometer through time, fully expecting to measure how much the expansion was slowing down, arguing only over whether it would slow enough to someday stop. That was the entire question. A lot of slowing, or a little. And in 1998, first in whispers, then in dueling announcements weeks apart, both teams reported the same impossible reading. The distant candles were too faint. Not by error, both teams had hunted their own mistakes for months precisely because they did not believe it, but truly too faint, sitting farther away than any amount of gravitational slowing could explain. There was only one honest way to read it. The expansion of the universe is not slowing down, it is speeding up. Somewhere around 5 or 6 billion years ago, right around the time our sun was young, the stretch of space stopped easing and began, gently and relentlessly, to accelerate as if the universe had crested a long hill and begun rolling downward with the brakes off. The ball thrown upward was not falling back. It was climbing faster every year, all on its own. You have to sit for a second with how upside down that landed. Gravity pulls. Everyone agreed gravity pulls. A universe full of matter should be reining itself in, and instead the reins were slack and the horse was quickening. The result was so unwelcome that the two rival teams, who might have relished contradicting each other, found themselves in the strange position of confirming each other instead, and that agreement, rivals arriving at the same wrong-looking answer through different data and different mistakes, is precisely why the world believed it as fast as it did. Within a few years, the measurement had been checked against completely independent witnesses, the afterglow of the beginning among them, and it held. It has held ever since. The people who measured it received the Nobel Prize, and cosmology walked out of the 20th century with a universe 2/3 filled with something nobody had ordered. That something needed a name, and the name it got, dark energy, is one more entry in astronomy's long ledger of honest labels for mysteries. A cousin of dark matter, but a different beast entirely. Dark matter gathers, dark energy spreads, and the strangest, simplest description of it is this: empty space itself appears to come with a faint, built-in push. Every cubic meter of vacuum, the purest nothing there is, behaves as if it carries a whisper of outward pressure, and because the universe keeps making more space as it grows, it keeps making more push, which makes more space, which makes more push. Matter thins as the universe expands, the push does not, which is why the young, crowded universe was ruled by gravity and slowed, and the old, roomy universe is ruled by the push and quickens. The handover happened while the Earth was settling into its orbits and oceans. We live just after the turning of the tide, and if the deepest identity of the push is still an open question, its pedigree is not lost on anyone. It behaves almost exactly like the term Einstein wrote to hold the sky still and then swept into a drawer in embarrassment. The strange key fit a lock after all. It didn't hold the universe steady. It sends it faster and faster into the dark. And before that sentence follows you towards sleep with the wrong weight, let's answer the question it naturally raises. Is the acceleration happening to you? Is the room stretching, the bed, the space between your heartbeats? No. Truly. Comfortably. No. The push of empty space is unimaginably faint, and it only wins where nothing else is playing. Across the huge empty gulfs between galaxy families, where gravity's grip has thinned to almost nothing, the whisper adds up over millions of light years into a shove. Anywhere matter has gathered, the whisper loses completely. Your body's chemistry ignores it. The Earth's orbit ignores it. The entire Milky Way and Andromeda falling toward us, and the whole bound household of our local galaxies, all of it holds together tonight and forever, a knot pulled tight that no amount of gentle stretching in the rest of the tablecloth will ever loosen. Dark energy empties the spaces between islands. It does not and will not touch the islands. Whatever else keeps you up at night, cosmic expansion has no claim on the list. So which ending is ours? Now, at last, the candidates can be weighed properly, and there are 3 on the table, and it is worth lying with each of them for a moment, because knowing why 2 were set aside is how you come to trust the third. The first is the big crunch, the ending everyone's intuition secretly expects, the throw that falls back. For the crunch, you need gravity to win, and gravity has lost the tug of war. The expansion is accelerating, and every year of acceleration makes a future reversal harder to arrange. It is worth one slow look at the ending we are not getting, if only to appreciate the one we are. A collapsing universe would run tonight's whole story in reverse, and the strangest part is how it would announce itself. Not with motion, but with warmth. The light of the far galaxies, compressed by the shrinking of space instead of stretched, would sharpen from red toward blue. The old cold glow of the beginning would begin, over billions of years, to warm again. 3 degrees, then 10, then hundreds, and the night sky itself, that reliable black cellar the Earth pours its heat into, would slowly become a ceiling, then an oven, until, in the last 100,000 years or so, the sky everywhere glowed dull red, brighter than any surface below it, and the stars ended not by fading but by dissolving into a sky hotter than they were. The universe would end in glare. All differences boiled away, the fire regathered by force. There is a real grandeur in it, but nobody would call it gentle. And the measurements, we can now say with relief rather than regret, point the other way. Unless the push itself someday fades or turns, and we will come to that honestly in a moment, the crunch is off the table. The universe is not coming back down. There will be no second fire, no great remelting, no cosmic bounce to begin the story again. Whatever the universe is becoming, it is becoming it outward. The second possible ending sits at the other extreme, and it earned the most dramatic name in the catalogue, the Big Rip. If the push of empty space were not steady but growing, strengthening within each region of space as time passed, then the acceleration would feed on itself beyond all limit, and the future would contain a schedule of unbindings. Galaxies pulled apart first, then star systems, then worlds peeled from their suns, then objects, then atoms. Everything opened in a final accelerating instant. It is a striking thing to imagine, and measurement after measurement has now walked it politely to the exit. The strength of the push, wherever we test it across cosmic history, sits steady, consistent with a true constant, not a growing one. The rip requires a fever, and the universe's temperature chart shows none. Cross it off, gently, and notice what you're left with. You're left with the quiet one. The push holds steady. The expansion accelerates forever. The galaxies thin out, the stars taper. The embers cool, the holes evaporate, and warmth completes its long retirement. The freeze, the fade, the heat death, the ending we have already walked. Of the 3 futures physics can write, the universe appears to have chosen the gentlest, the one that takes the longest, the one that ends not with an event but with a settling. When the title of tonight says, "The universe is dying for a reason," this is the reason, named and measured. Space itself carries a push that will never let the fire regather, and a fire that cannot regather can only spread. And spreading, thin and thinning, cool and cooling, rest. The universe dies the way it does because emptiness itself insists on more room. Now the honest asterisk. Because this channel keeps its promises about hedges, and this one is genuinely exciting rather than worrying. The verdict of the freeze rests on the push being truly constant. And in the last couple of years, the newest generation of galaxy surveys, mapping tens of millions of galaxies with robotic precision, has returned the first whispers, and whispers is the right word, that the push might have weakened ever so slightly across cosmic time. It is far from settled. The hints sit at the level where careful people lean in rather than declare. But if they harden, the textbook future would reopen, because a push that can weaken is a push that could, conceivably, on timescales beyond all reckoning, fade or even turn, and the drawer with the crunch in it would creak open again. Hold this the way the discoverers hold it. Not as doubt about tonight. The dying itself is not in question. Only the far shape of the final chapter, and every version of that chapter still lies trillions upon trillions of years beyond every star you will ever see. The fire burns down in every future physics can currently write. The surveys are merely arguing about the arrangement of the last embers. There is one more consequence of the acceleration, though, and I've saved it for its own moment because it is the strangest and, in a quiet way, the most personal. An accelerating universe grows a horizon. As space stretches faster and faster, there is a distance beyond which the stretching between us and a far galaxy outruns light itself. Not because anything travels too fast, but because the road grows quicker than anything can walk it. Every distant galaxy is drifting toward that edge. One by one, over the coming tens and hundreds of billions of years, the galaxies you can see in tonight's deep photographs will slip across it. Their light stretching and slowing and freezing into the dark, leaving our sky forever. The great pantry closes not by emptying but by leaving. In the deep future, the merged household of our local galaxies, the calm elder galaxy that the Milky Way and Andromeda will have become, will be, for all purposes, alone, an island of embers in a sea of nothing observable at all. And here is the part I find genuinely moving, the part that turns all this from a forecast into a kind of instruction. Think of the astronomers of that far future, whoever they are, whatever they're made of, standing under their island sky of old red stars. They look out with instruments better than anything we own, and they find darkness, one galaxy, and darkness. All the evidence we used tonight has left. The fleeing galaxies that revealed the expansion are gone over the edge. The afterglow of the beginning, that faint old warmth that told us the universe was once an oven, will have stretched so thin as to be undetectable. Every clue that points to the Big Bang, to the age of the universe, to the existence of anything beyond their island, will have quietly boarded the horizon and departed. They will do everything right, and the universe will tell them, honestly, from every direction, that it is small, old beyond guessing, and alone. They will be wrong through no fault of their own. Wronged not by bad science, but by a sky that has stopped keeping records. Remember the civilization we imagined near the top of tonight, growing up inside a void, misled by an empty sky. In the deep future, that civilization is everyone. There is one gentle loophole, and thinking about it is one of the kindest games in cosmology. Records survive inside the island. If anything endures across those gulfs, libraries, monuments, memory in whatever form 100 billion years permits, then the far future's only knowledge of the wider universe will be inherited, not observed. Old charts of galaxies no instrument can confirm, measurements of a warmth no antenna can find, the testimony of ancestors who lived when the sky still confessed. Their scientists would face a strange inversion of our situation. Evidence too old to check, describing a cosmos too generous to believe. Whether they would trust it is a question about them, not about physics. But it does mean that what we measure now, in this brief bright age of evidence, is not just for us. It is, potentially, the only inheritance on the subject there will ever be. Cosmology, done tonight, is a letter to readers who cannot write back. It is worth doing carefully for exactly that reason. And, for what it's worth, the people doing it know this. And it shows in how carefully they work, which means something rather wonderful about right now, and I want you to actually hear it before we head toward the ending. We happen to be awake in the narrow, privileged age when the universe still shows its workings, when the fleeing galaxies are still visible to confess the expansion, when the old warmth of the beginning still hums faintly in every direction for our antennas to find. That warmth, by the way, is not an abstraction. It was discovered by accident in the 1960s by two radio engineers, Arno Penzias and Robert Wilson, who could not scrub a stubborn, faint hiss from their horn-shaped antenna in New Jersey, and who checked everything. The wiring, the seams, the pigeons roosting in the horn, before accepting that the hiss was coming from the whole sky at once. It was the glow of the universe's first age, cooled by 14 billion years of stretching from a blaze to a whisper, 3 degrees above absolute zero, still arriving, still everywhere. A fraction of the static between stations on an old untuned television was that same first warmth, passing through your living room on its way to colder places. We live inside the universe's memory, while the universe still has one. The evidence of the beginning is, right now, draining toward the horizon on a schedule of billions of years, and we, by pure calendar luck, are here while the library is still open. Here's a small aside from the temperature ladder that I think you'll like, because it turns the whole cold story briefly upside down. 3 degrees above absolute zero, the current temperature of the deep sky, is cold beyond anything natural on Earth, and yet the coldest places in the known universe are not out there at all. They are in laboratories on this planet, where physicists routinely chill small clouds of atoms to within a billionth of a degree of absolute zero, colder than any naturally occurring place we have ever found, colder than the deep future itself will manage for a very long time. Even nature's own record holder is charmingly local. A dying star's expanding breath called the Boomerang Nebula, about 5,000 light-years away, has cooled itself by sheer speed of expansion to a single degree above zero, making a small cloud around one modest star briefly colder than the entire rest of the cosmos. The universe as a whole will take countless ages to reach temperatures that a basement full of graduate students reaches before lunch. It is a gentle reminder that the great cooling is not some alien force. It is ordinary physics, the same physics we bottle and study, arriving everywhere at its own unhurried pace. It's fair to ask, at this depth of the night, how much weight forecasts like tonight's can really carry. 100 zeros is a lot of confidence. So let's grade the forecast honestly, piece by piece, the way you'd grade a long-range weather service. The near chapters are as solid as science gets. The sun's swelling and settling rest on the same physics that lights it this morning. Physics checked against millions of other stars caught at every age. A life cycle we have essentially photographed end to end across the galaxy's population. The tapering of star birth is not a prediction at all. It is a measurement, already made, already deep underway. The cooling of embers is thermodynamics, doing what thermodynamics has never once failed to do. Further out, the grades stay high but the hedges appear, and we have flagged everyone tonight as we passed it. Whether protons dissolve, whether the push of space holds steady forever, what deeper laws might wait beneath the ones we have tested. And the honest summary is this. The broad shape of the story, warmth spreading, structure settling, the fire never regathering, sits on the most repeatedly confirmed law in all of physics, while the fine print of the final pages is still being argued by people who love the argument. Tonight has told you the map as it is currently drawn, hedges included. That is all any weather service owes, and this one has the unusual honor of forecasting only calm. And now we can turn the whole night over, because we've earned the turn. We know what the dying is, warmth spreading, arrangements settling. We know the schedule, stars tapering, embers cooling, the long dark ages patient beyond words. We know the reason, A universe whose own emptiness insists on more room, so the fire can never regather. Which leaves the question that was hiding inside the title all along, the question that isn't really about the universe at all. If all of it is winding down, if every candle ends and even the darkness has an ending schedule, what does that make of the middle? What does it make of tonight? Of your bed, your breath? The small, warm life you will pick back up in the morning. A reasonable, sleepy mind, arriving here, wants to ask, is any of it pointless then? And tonight has an actual answer. Not a consoling shrug, a real one. And it comes straight out of the physics. So let's take it slowly. Like the last flight of stairs before a landing, start by imagining the alternative. Honestly, imagine the universe the intuition seems to want, one that never runs down, one already settled into perfect balance, everything at the same temperature, everything evened out, nothing owed anywhere. Physicists can describe that universe exactly, and the description is short. Nothing happens. Not slowly, not rarely, never. Because happening, all happening, every single event since the beginning, is warmth moving from a warmer place to a cooler one, order becoming motion, becoming other order. A universe in perfect equilibrium has no warmer and no cooler, no here that differs from there, and so it has no next. It cannot make a wave, or a wind, or a heartbeat, or a thought. It is not a peaceful universe. It is not even a boring one. It is a universe in which the word event has nothing to point to, a clock with no hands, a stage with no play, forever. The settled state we have been calling the ending is not some enemy that invades the universe. It is what a universe looks like when nothing more can be spent. And that means everything you have ever called an event was precisely some of the spending. Physicists have a beautiful, stern way of putting this. You cannot draw work from heat unless the heat has somewhere cooler to flow. A fire in a fireplace warms the room because the room is cold. Put the same fire in a room already at the fire's temperature, and it becomes a painting of a fire, radiating nothing, powering nothing. Every engine humans ever built, steam, petrol, jet, is a machine for standing in a flow of warm to cold and taking a toll as it passes. And every living thing is the same machine grown soft and clever. The universe runs on difference, not on energy. Energy is conserved forever, never lost, but difference is spent, and difference is the only currency that buys events. So here is the whole night in one sentence. Worth keeping under the pillow. The universe is not running out of energy, it is running out of difference, and everything you love happens in the spending. Now look at where you live. Because once you see it, you cannot unsee it, and it is the best example in the known universe. Earth sits in a flow. On one side, the sun, 6,000 degrees at its surface, pouring concentrated golden light onto our world's day side. On the other, the night sky, 3 degrees above nothing. An endless cold cellar into which the Earth radiates its warmth away in the infrared every hour from the whole of its surface. In and out, almost exactly balance, the planet barely changes temperature. But, and this is the secret of everything, what comes in is not the same kind as what goes out. For every single packet of concentrated sunlight the Earth absorbs, it releases roughly 20 packets of tired, spread out warmth into the night. Same energy, 20 times more settled. The Earth, in other words, is a water wheel standing in the stream between a star and the dark. And the toll it takes from that stream is not energy, which it returns in full, but order, difference, usefulness. And with that toll it pays for absolutely everything. The winds, the rains, the ocean currents, the greening of every leaf, the entire history of life, your body, your breakfast, and the thought you are having right now. Sunlight in, 20-fold tiredness out. And in between, in the gap, a world happens. Watch the wheel turn once in ordinary weather, because you have seen this machine work your whole life without being introduced. The sun lays its warmth unevenly on the world, more at the equator, less at the poles, more on land, less on sea, and the atmosphere, obedient to the law, sets about evening the difference, and its evening out is what we call wind. Warm, wet air rises, hauls ocean water into the sky, spends its warmth aloft, and lets the water fall, sorted and fresh, onto hills it then runs down as rivers. Every drop of rain is the flow doing paperwork. A thunderstorm is the same errand run in a hurry. A tall, magnificent machine for moving a surplus of warmth upstairs, throwing lightning off like sparks from the effort. Even the slow patience of a glacier, even the trade winds that carried the old sailing ships, even the particular softness of tonight's air in your room, all of it is the one law, evening things out, and the whole restless, beautiful weather of Earth is what it looks like when a planet stands in a stream of starlight and lets the stream through. The world is not busy despite the great settling. The world is busy with it. Life, seen from this angle, is not a rebellion against the running down. It is the running down, grown artful. A living thing is a little standing whirlpool in the flow, like the spiral that forms above an open drain, holding its shape beautifully while everything that makes it passes through. You have replaced nearly every atom in your body many times over. The pattern stayed, the water changed. One of the founders of quantum physics, Erwin Schrödinger, wrote a small famous book in the 1940s asking what is life, and his answer, decades ahead of its time, was thermodynamic. A living thing keeps its own order by drinking order from its surroundings and paying out disorder in exchange. Sunlight for body heat, structure for waste, always running the toll booth, never once breaking the second law. Every organism that has ever lived has been a loyal servant of the very law that ends universes. The dying we have been describing all night is not the thing that will someday stop life. It is the thing life is made of. A universe that could not die, could not live, and there is no way to have the whirlpool without the drain. Follow the toll booth chain once, leave to bed, because it is a bedtime story all by itself. A photon of sunlight, 8 minutes off the sun, lands on a wheat leaf in a field somewhere, and in less than a trillionth of a second, the leaf's machinery catches its energy and locks a piece of it into sugar, the first little volt of order. The wheat spends some, stores some in the grain becomes bread, the bread becomes you. Your body burns the sugar with the oxygen you are breathing right now, and spends the proceeds on heartbeats, on repairs, on keeping your temperature at its steady warmth, on the slow consolidations of memory your brain is preparing to run tonight while you sleep. And at every single link, some warmth is paid out into the air. Tired light bound for the cold sky. The toll the law collects at every booth. Nothing in the chain cheats. Nothing runs uphill. And yet look what got built along the way. A field, a harvest, a kitchen, a person, a night's rest. That is the whole trick of the biosphere, and it is the only trick life has ever had. Stand in the flow, take the toll, build something lovely, pass the rest along. 4 billion years of that. Unbroken is what you are, and the flow shapes more than bodies. It shapes the whole feel of being someone. Your memory works one way, from the settled past toward the open future, because recording anything, laying down a memory in a brain, is itself a little act of spending, possible only in a universe still running downhill. Your choices feel like they matter because they sit on the same slope, deciding is spending too. Even meaning itself, if you follow it down far enough, is a creature of the gradient. Things matter because they are not yet settled, because the story is still being written, because tonight is genuinely different from tomorrow. In the equilibrium universe, nothing means anything, not because meaning was banished, but because there is no difference left for it to live in. Meaning is the shine on the flowing water. Still water holds no shine, and if you want the spending made personal, you are wearing the receipts. Every atom in your body heavier than the primordial hydrogen was forged in the great spending. The carbon in your skin and the oxygen in your lungs assembled in the cores of stars that spent themselves before the sun was born, the calcium in your bones scattered by their final unravelings, the iron in your blood, the exact iron carrying oxygen through you as you read this, cooked in the last hours of giant stars and thrown into the dark by the very detonations we use to measure the universe's fate. You are not merely powered by the dying downstream of one star's warmth, you are built from it, from the ash of many. Assembled and reassembled across 3 generations of stars before any of it agreed to become you. The universe spent 9 billion years of stellar lives preparing the ingredients of one drowsy reader. When people say the cosmos is indifferent, they are usually looking at the dark between things. Look instead at the ledger. Something that spends 9 billion years of starlight on your bloodstream is many things, but it is hard, lying here in the warm, to call it indifferent. And when the sheer finality of it all brushes past you again, as it may, some night, long after this video is forgotten, here is the small human answer to keep in the drawer by the bed. Nobody lights a candle expecting it to burn forever. The lighting is not a mistake corrected by the burning down. The burning down is the candle doing precisely what candles are for, and the little while of light is the entire point, not a flaw in it. The universe, by every measurement in tonight's story, is a lit candle, the grandest one there will ever be, and everything you have ever loved has happened inside its little while of light. The physicists of the 1800s discovered the wax is finite. The physicists of 1998 discovered no draft will snuff it early. It gets to burn all the way down, undisturbed, at its own pace, for longer than numbers comfortably describe. Between those 2 facts sits everything. The flame is temporary, and the flame is safe. That is not a tragedy with extra steps. That is, very nearly, the definition of an evening. There's a bigger version of that thought, and it deserves its own quiet minute, because it changes where you think you are in the story. We tend to assume the universe's best age was its youth, all fire and first light, and that everything since has been decline. The physics says otherwise. The very young universe was too hot and too smooth for anything interesting, no chemistry, no structure, just glare. The very old universe will be too cold and too thin, no flows, no gatherings, just calm. Complexity, all of it, everything with parts and patterns and stories, lives in the long middle, on the slope between the two, where the universe is still wound enough to spend but settled enough to build. Stars, galaxies, planets, chemistry, biology, music, grandmothers. Every one of them is a middle-age phenomenon, impossible at the start, impossible at the end, at home only in the era of the great spending. And we are in it, deep in it, with trillions of years of slope still below us. The universe is not past its prime tonight. By the only measure that produces anything, richness per era, the prime is enormous, and it is now. And now is scheduled to last a very, very long time. Even the phrase mostly finished, which we used for the star-making, deserves one final turn in the light, because percentages hide things. Yes, some 95% of the stars that will ever exist have been born, but 5% of a number that large is not a remainder. It is trillions upon trillions of suns still to come. Whole unborn generations, each with its retinue of worlds, its chances at oceans, its possible quiet evenings. The universe's remaining to-do list, read as a list rather than a fraction, is longer than anything in its past. And every one of those futures will run on the same waterfall yours does. The orchard's last plantings alone outnumber every star humanity has ever catalogued, and they have not happened yet. It is a strange kind of dying that still has trillions of dawns in its pocket. And if you want the whole of tonight in an object, it is probably within reach of your hand. A warm drink on a nightstand, cooling. That's it. That's everything. It was heated on purpose. By spending, it is giving its warmth to the room, which is the only thing warmth ever does. It will be room temperature by morning, and no law in existence can march its heat back in. In the little curl of steam off a mug, you can watch the same law that will someday retire the last black hole. The universe does not do different things at different sizes. It does one thing, at every size, at every speed, from the teacup to the total. It shares its warmth until the warmth is common. And knowing that, there is something almost ceremonial about the last sip of anything warm at night. You are taking your inheritance directly, 1 degree at a time, from the only fire there has ever been. It's worth being honest about the one debt tonight cannot pay, because this channel doesn't hide its seams. Everything we've told traces back to that first fact, the wound spring, the impossibly smooth, low-entropy beginning that loaded the universe with all the difference it has been spending since. Why the beginning was like that, why the universe started its story at the top of the slope rather than the comfortable bottom, is still, truly, unknown. There are serious ideas about the violent stretching of the first instant smoothing everything it touched, about deeper laws, about origins beyond our current mathematics, and none of them has yet closed the case. It is one of the deepest open questions a person can ask, and you have now actually asked it tonight, half asleep, which is more than most of the loudest people on Earth can say. Sleep on an open question, and it keeps quietly working for you. That one has been working on physicists for 1.5 centuries, and because careful people also keep doors ajar, let it be said softly that the very far future has a few of those too. Some physicists explore whether, on timescales that make even our 100 to 0 numbers look brisk, the restlessness of empty space might rarely and randomly stir, whether ended universes might fluctuate new beginnings, whether the story could, in some mathematical tellings, run again. Others have built careful cyclic pictures, where endings and beginnings lean on each other forever. These are speculations, clearly labelled, argued in journals rather than settled in textbooks. And tonight owes them exactly one breath. The door to forever is not known to be locked. Physics has closed none of the deepest doors, only mapped the corridor. Where the corridor is measured, we have told you what the measurements say. Where it is not, tonight has tried to say so plainly, and leave the dark ahead as what it honestly is, which is unread, not written. Before we start back down, spend one last practical minute with the night sky you actually own. Because after everything we've walked through, the view from your window has quietly changed, and it would be a shame not to collect the winnings. The next clear night, look up and know that you are watching the great spending in progress. Live. Arcturus, the warm orange beacon of northern spring evenings, is an old star, already swollen and settling. Further along the road, our sun will take. Betelgeuse, the red shoulder of winter's great hunter, is a giant near the end of its spending, due in the next 100,000 years or so, to end as the brightest thing anyone on Earth has seen in the sky after the sun and moon. A farewell visible in daylight. The brilliant white of Sirius drags along a companion too faint for your eye, Sirius B, a genuine white dwarf, an actual ember of the kind the far future will be made of, orbiting the brightest star in our sky, like a full stop waiting at the end of a sentence. The static that fuzzes an untuned radio still carries its little share of the beginning's warmth on its way to the cold. and the darkness itself, the plain black between the stars that you have seen every night of your life, is the oldest evidence of all. Because in an eternal, unspent universe, the night sky would blaze solid with the light of endless suns, and it does not. The dark you fall asleep under is the universe telling you, gently, every single night, that it began, that it is spending, and that the story is still in the middle of being told. So let's go back down now, the way you came, warm step by warm step, and let the whole night settle into order behind you. You began beside a fire in a stone hearth and learned its one rule, that warmth spreads and never regathers, and that entropy is just the count of the settling. You met the arrow of time, and Boltzmann, who carved the counting on his own gravestone. You watched the fire of everything be lit, impossibly smooth, wound to the top of its slope, and you learned the finest secret of the early universe. That smoothness, with gravity waiting, is a loaded spring. You watched the first star switch on, and understood the stars for what they are, the great spending organized into light, and yourself for what you are, a warm eddy far downstream of a long golden waterfall. You stood in the orchard of the late summer universe, saw the planting mostly finished, and met the patient little red stars, who will keep the lights on for trillions of years after the giants have taken their bows. You watched our own sun swell, exhale its veils, and settle into an earth-sized ember that will outlast every calendar. You walked the quiet ages, embers to black dwarfs, the possible dissolving of matter itself, the black holes giving themselves back one whisper at a time, the last flash, and the long, even dark where warmth itself retires. You solved the mystery of the ending's shape, with two rival teams and the detonating embers of dead suns, and found the reason in the drawer where Einstein left it. Space itself pushes, the fire can never regather, and the gentlest of the three endings is the one that's true. You watched the far galaxies drift toward the horizon, and understood the privilege of an early seat, here, in the age when the universe still shows its workings, and at the bottom of everything you found the turn. That a universe that could not die, could not live, that difference is the only currency of events, that meaning is the shine on flowing water, and that the ending, patient beyond all patience, is not the story's enemy, but its engine. Now, there's nothing here you need to hold on to. No dates to keep, no numbers to remember, not even the beautiful stern law which will go on working perfectly whether or not anyone remembers its name. Let the embers and the ages and the long dark drift apart again, the way warmth leaves a teacup, slowly, softly, without asking anything of anyone. Let your shoulders settle. Let your breathing find the pace it wants, the way every flow tonight found its own pace. Downhill, unhurried, sure of the way. And there is one last secret hiding in tonight, the closest one of all, which is that sleep itself belongs to the story. While you rest, your brain runs its own quiet version of the universe's great work, sorting the day's disorder, filing what mattered, rinsing away the residue of thinking, spending a little warmth to leave things tidier by morning, which is why a slept-on problem so often solves itself, and a slept-on sorrow so often softens. Falling asleep is not stepping out of the flow. It is trusting it. The way you trust a river you have floated in every night of your life. The same law that banks the fire and settles the tea and walks the universe patiently toward its rest is, right now, ready to tidy one small warm corner of it on your behalf, free of charge, before the light comes back. The universe is spending its warmth on you tonight, as it has every night of your life. And it has trillions of years of warmth left to spend. The fire is banked, not out. The orchard is golden, not bare. And the long dark, when it comes at last, will come the way sleep comes, without an edge, without a sound, to a universe that spent everything it had on stars and mornings and creatures who could wonder about it, one of whom is now, finally, drifting off. If you're still awake and you'd like one more journey, there'll be another one waiting on the screen to carry you onward. Otherwise, just stay here in the warm. The stars will keep spinning while you sleep. Good night.